Amazing. It's awesome to be here today. Chain React in Portland, what a place to be. And hey everyone, I'm Taz Singh, and this is a photo of me with Mark Dalgleish. I had the pleasure of chatting with him down in Australia, where this photo was taken right after he said, wait, you're shipping React Native to the web? Why in the world would you do that? And so, if you don't know Mark, he's the creator of CSS modules, Vanilla Extract, and he's prolific in the React design system space. He's also worked on React Native design systems over at Rainbow, where he's doing awesome work today on the Remix team over at Shopify. And so this is the answer I gave to him back then. I started off by saying, well, Mark, this is why. Guild is a platform for communities, and communities exist everywhere. They exist in all shapes and sizes. We need to build an application that also exists everywhere and can exist in whatever shape and size these communities come in, on all of the platforms they're on and all of the platforms those users are on as well. Today, if you're building a modern application, you need to cater to both mobile and desktop anyway. Looking at the usage metrics of Guild, 51% of our users are accessing it on mobile devices and 49% on desktop. And this makes sense because people are interacting with the platform on the go, they're looking at new events to attend or watching presentations. For us, we're also an early stage startup with a small team. We need every member of our team to be as effective as possible when shipping code. Every change to our code base needs to have the highest impact possible. However, if we ship code to every platform, we also need to support and test all of them. We need to test against every web browser. We need to test against every mobile operating system. It's the same for desktop as well. We need a bunch of physical devices for all these platforms, such as low-end Android devices and so on. You can imagine additionally supporting multiple languages, such as English and Spanish, where the number of items to test and support would start to increase exponentially, and adding new features to the platform would be more and more difficult. That's why today we're focusing on just the web platform in English for the moment, to keep the support overhead manageable, essentially in our early stage. I see it working a bit like this, where the web platform is what we're building for today. Once we introduce iOS and Android, we can see it working a bit more like this, where there's some overlap of commonality in the middle, let's say. And as we layer on things like macOS, Windows, Linux, and so on and so forth, the diagram might start to look a bit more like this. And for me, that's really the power of leveraging React, where I see it being a superset of all of these platforms in that React Native can encapsulate the logic and orchestration for all of them. So let's dive into React then, shall we? So what exactly do I mean by that? Well, let's say you have an app in React that looks like this. It renders just some component, right? And that component, maybe you pass in data into it and you get data back out of it. That underlying component itself could be doing anything. That could be written in React Native. That could be pulling in a React Native view and rendering to a React Native text component. That component could be rendering to HTML elements like in a manner like React DOM. That component could be rendering to some native view that's entirely platform specific, right? The nice thing about React Native, and in our case Expo, is it makes it easy to write the common code on the left and then overwrite that with something more platform specific towards the right just by file naming convention. We always start with the common approach provided by Expo, and then when we need to reach into the platform itself, we can create a more specific component for that just with the appropriate extension and so on and so forth. Because remember, the contract remains the same. It's just a React component that's passing data in and getting data out. That's it. The composability of this model is what really makes it all possible. And for me, it doesn't feel like I'm giving anything up. It doesn't feel like I'm being let down. It doesn't feel like I'm being run around and deserted. Now, while you could drop down to a platform-specific override, and you could technically write a fully functional web application in that, you can have a top-level app.web.js file and write a fully React DOM, everything inside of that if you wanted to. We've actually found that React Native components are more predictable. So what do I mean by that? Well, just looking at the React Native docs, these are the underlying components that you build a UI out of. There's buttons, lists, forms, modals, and so on, all provided by React Native itself. And now let's compare that to the web platform, shall we? Where I'm just scrolling through MDN's documentation on this, and you can see the red outline following me on the right there. There are far more primitives to choose from when building a web application. Sure, it's not an exact one-to-one match, and it's not quite an apples-to-apples comparison, but my core point still stands, is that there's way more going on with the web platform compared to the more focused set that's provided by React Native. And the nice thing about this is that by being more focused, things like browser compatibility is much easier to provide out of the box. This is a list of compatible browsers provided by React Native Web, which is what we're using to render our React Native application on the web platform. Okay, so let's say you're writing components in React Native itself and you want to use something that's incompatible. So let's say you're trying to do this and you're trying to create a CSS backdrop filter to create like a blur effect on that element. This is where TypeScript comes in handy because it kind of nicely highlights that that's incompatible for me. Now, this actually works fine through React Native Web. It'll just pass right through and it'll actually render that property in CSS. But what if we wanted to do that on other platforms as well? Well, that's where Expo SDK has most of what you need. Just by looking at their docs, we can see that the blur view, and it actually has platform compatibility listed right there. We can see it's supported on the web as well as iOS. But then what do we do for Android? Well, a quick search led me to this library, React Native Community Blur, which provides the same functionality in Android. And so just by naming these files more specifically again, we can get an experience that works everywhere for all platforms. And Expo has a bunch of these other components and APIs that you can leverage when building a cross-platform application, such as Expo AV. You can see the platform compatibility there once again. ExpoGL view, if you're rendering OpenGL. So this is, again, compatible across every platform they support. On web, it just renders to WebGL, and the list on Expo just keeps going on. They have a ton of things kind of built into Expo itself, and you can leverage any of these as you're building your application. The crazy thing is that all of this actually works in any non-Expo React Native app, as well as any non-Expo web app, which is kind of insane to think about. I haven't tried that myself, so I can't speak about my experience using that, but I know it's technically possible, so you can go try it for yourself as well. All of this is possible because components are the building blocks of React Native. We think in components first, and we compose components to make applications. We don't think about style properties in the same way, for example. If you want to blur something, you just compose in a blur view instead of thinking about the particular CSS properties to make that thing blurred. And in my opinion, React Native is more true to the React model of component composition because of this. For me, when I use React DOM, it feels a bit less pure in a lot of those ways. Cool. So that's basically how we develop using React Native's core component model. And as you can see, it is everything we need. We don't really feel left out because we can always drop down to something more platform specific and compose that into components as we go along. But how do we build an actual application out of this? How do we actually use that and build something meaningful? Well, I'd recommend checking out the presentation I gave last year called React Native Everywhere. You can find it by going to my profile on Guild and checking out the presentations I've given. I go into much more detail on React Native design systems and navigation, so I'd recommend checking that out. But to give you the short and sweet version, if I was to start today, I would just use Tamagui. It's an excellent design system. It's styling, an optimizing compiler, and a UI kit that unifies React Native and the web. I had the pleasure of hanging out with the author, Nate Weinhardt, last week at AppJSConf, where we chatted on camera about Tamagui, and that'll be up on my Guild profile once we release that interview. I'd recommend checking that out for a much deeper dive. In essence, however, the optimizing compiler for React Native applications creates straight platform-specific code for your application. This screenshot shows how generic React Native code in the Tamagui design system on the left compiles down into web platform on the right. So just by looking at the code on the left, you see it's just using a stack component for layout, a heading component for text, and that's it. That's all you really have to think about. You've got to think about the high level of what you need to do for your application's UI. It's highly declarative, and you don't need to think about those intricate, small little details. And so we don't actually need to think about the compiled output, but let's just take a moment to kind of focus on that a little bit more. You can see that it essentially looks like what you would write if you were to write highly optimized platform-specific code using React DOM directly and CSS variables for everything. It's using semantic HTML compiled down to a div and an h1 tag in React. And the CSS uses the appropriate media queries and everything. It is as native can be on the web platform. This works incredibly well, where again, you can just use those higher level components and not have to worry about how it compiles down to the platform. So in my opinion, any serious application should be using a design system, and Tamagui is an excellent one, so I'd recommend checking them out for your design system as well. To stitch it all together, I'd recommend checking out React Native URL Router. That's what we're using. It's essentially React Router with all of its state management goodness, plus it pulls in React Native screens to provide a truly native feel on non-web platforms as well. As we're currently building for web, we're currently using React Router directly, and we're planning on pulling in just the 2 components needed to swap out for non-web platforms on React Native URL Router once we build for those platforms as well. And so, since we're rendering for the web, there's kind of one key feature that we need that you don't really need if you're not building for the web, and that's server-side rendering for React Native. Because we're building a consumer application, it's of very high importance to have great SEO and great performance as well. So how do we do that for React Native? Well, I'm sure when I say this, a lot of you are thinking about Next.js, of course, and while yes, they do have a fantastic server-side rendering engine built into it, spent a ton of time optimizing it, and it's a fantastic framework for a multitude of different reasons. It's not really a fit for us, because if we were to use Next, we'd have to build on top of their router, and while that's fine for web, of course, once we go into other platforms, we'd have to have a separate navigational stack for all of those. So we basically have 2 entirely different navigational stacks that we'd have to support. It wouldn't really help us to unify our code across different platforms, and would just fundamentally just create more work for the team and more areas of inconsistency for our experience. So we didn't go with Next. There's of course Remix, which also has a fantastic server-side rendering pipeline built into it. And right now, I would say probably our stack is most aligned with Remix, as we're currently using React Router, which also powers Remix. But again, they don't have React Native URL Router built into it. And so moving forward with Remix would mean we'd need something kind of different there as well. But perhaps it's a bit less intrusive for us. Perhaps they can support that in the future. And really, any of these options are fantastic for you if you wanted to render a React Native component on the web. All of these work fine. For us, it's really just a matter of navigation and unification across platforms. So that's why we haven't gone with these options. I'm personally really curious where Expo will land on the recent work with Expo Router. Conceptually, I believe that to be the most future-facing solution that works well with the majority of how we build our app. But Expo Router just isn't quite there today. They don't have server-side rendering on the web and other features such as code splitting, which we need. With Expo Router v2, however, you can render your React Native app to static files and host that, which will obviously be rendered on a server. But we require active server-side rendering, which just isn't there yet on Expo Router. I'm also a little bit skeptical of React navigation on the web, as I have a feeling that because it ships UI code coupled to the routing itself, it would result in a larger bundle. In every project I've worked on, I've just overridden the React navigation UI anyway, so I prefer to have this more decoupled. But sadly, it's just not there, again, today, and we need to ship code today. I know the team there is smart, and they're highly aware of everything that's needed. They're working really hard towards it, and all of these things are fixable. Like, nothing I said can't be done. They all, of course, can be done, and I know they'll execute well on this in time. So we're going to keep a very close eye on this, and maybe we'll move over to it in the future. But fundamentally, what do we do today? I guess we'll just have to build it. And so what we built was a server-side rendering pipeline on top of Cloudflare workers to power Guild's web experience. It utilizes all of the latest features in React 18's concurrent rendering to stream over a response to the end user. Cloudflare informs us of the user's device type that we then use to server-side render directly into the breakpoint that they'll be accessing our experience from. And that's because React Native itself uses the window dimensions API to do things like this, and not media queries unless you're using Tamagui. This is currently a gap if you're using things like Next or Remix or so on and so forth, and that they don't really do that. So actually building a custom approach has provided a better experience just by building it ourselves. Since we're also using Relay for our data fetching via GraphQL, we're able to embed the entire page's data dependencies into the payload to avoid refetching on initial load. That way, the end user just loads the page and it's just there. It just works. So feel free to give it a shot. Just load up our site guild.host and have a look for yourself. It works pretty well, I think. But fundamentally, the reason why any of this works is because it's native. React Native is native. It's not React Mobile, it's not React Web, it's React Native, because you can create truly native experiences on any platform. So on the web platform, it's just like any other web application that you'll be rendering via React for that, right? So all of these things just work. Therefore, we can server-side render a React Native web application in the same way. You can do it with Next and Remix, because those are React frameworks, of course, and so since React Native Web is just web, you can totally do that. But fundamentally, all of this got me thinking, if React Native is truly native, can I stitch React Native into any other application regardless of how that application is built, right? I mean, Facebook's app is technically just React Native stitched together along native views, right? That's kind of how that works. If the technology can do that, is it possible for us to do that for everything else as well? And so we tried doing exactly that. We actually built Guild's Embeddable SDK, which we've basically taken all the different building blocks of our UI, created using React Native Web and powered by Relay for declarative isolated data dependencies. And we provided a JavaScript library that folks can just natively embed into any page. You can just load in the script tag, and that loads in our SDK, tell it where to mount using the div tags, and that just works. This is not using iframes. This is actually native elements on the same page. And we're not using iframes because you can't operate outside that frame. So if we wanted to open a modal, for example, we couldn't do that inside an iframe. We need an actual element rendered on the physical page to open a modal. And you can see this if you go to the code sandbox link above. It's that MXCFMH link at the very top there, and have a look for yourself. It's, again, fully native on the web platform, and it's a JavaScript SDK just like you would have anything else. With this approach, you can take our event component and directly embed that on your conference's website, for example, and do ticketing through Guild. You can take a presentation component and embed that on your own personal portfolio site and have a history of all the different presentations you've given. Fundamentally, you can actually recreate our entire UI if you wanted to, giving you an easy path forward to deeply and easily integrate into any workflow that you might have for your community. So this is what I mean when I say communities are everywhere. They come in all shapes and sizes, and we have to be as well. With our React Native embeddable strategy, we can truly be everywhere. Now, I know what you're thinking. Wait a minute, but this is for the web. This isn't truly everywhere. It's not on other platforms yet. And well, yes, you'd be correct. We're currently just building for the web platform. However, this is not my first rodeo embedding React Native into other platforms as well. And so I'm not actually sure if I'm allowed to say this or not. Is Ken here somewhere? Is there an organizer somewhere? Am I allowed to say? Ken, am I allowed to say this word?
No!
What?
Day and a half, bro. We made it through a day and a half. Nobody said no filth or flooring. No.
I can't say it?
No. Get off screen. No. You got young impressionable Jacobs right here. You can't handle this kind of stuff. No, get off screen. No.
Well, now that he's gone, I'm going to say it anyway. Flutter. Yes, that's right, folks. In the past, I've embedded React Native directly into Flutter. I was consulting for a large Fortune 100 company where one team chose to use Flutter and another team chose to use React Native. However, the business wanted one consumer-facing application. And so either the Flutter team would have to recreate everything the React Native team was doing, or the React Native team could build everything the Flutter team was doing. I know what you're thinking. I mean, don't get me started. That was just a challenge I was given and I had to solve for, right? So fundamentally, I mean, like, what if we could just put one inside the other, right? And for me, I kind of knew that if we could actually stitch React Native into Flutter, then I know like truly anything's possible with this technology, because I'm sure a lot of you are skeptical about this, just like I was. And that's because Flutter renders very differently than React Native. Flutter essentially renders to a canvas, and we can see that in the top screenshot is just kind of one native view, while React Native renders a full tree of native views, which we can see on the bottom there. And to be clear, I'm not criticizing one approach over the other. That's just how it works. They're just different ways of building applications. They all have their own benefits. So that's cool. But for us, it got me thinking, yeah, can we actually embed React Native into Flutter? Can we take those same React Native components and truly put that inside any platform, regardless of how it's built entirely? how native is React Native really? And so turns out, yeah, you can actually embed native views into Flutter. So under the hood, Flutter takes screenshots rendered on a separate area and composites that into the Flutter canvas. It does come with a performance hit inside Flutter, as you're no longer rendering inside Flutter's highly optimized canvas, but this method does technically exist. And it makes sense because it's not entirely feasible for Flutter to just rebuild everything, right? If you're using maps, for example, it doesn't make Flutter to just rebuild an entire maps widget inside Flutter. You'd want that to be kind of the native maps that you have on the platform and kind of pull that into Flutter. So for our needs with React Native, we can actually follow along with this and also embed our React Native components directly into Flutter. In the past, our example of this was able to directly feed props from Flutter directly into React Native, and that was just straight up props inside React Native. And the crazy thing was handlers inside like React Native just looked like actual handlers back out in Flutter as well. So our React Native components appear to be just any other Flutter widget, and it was actually entirely native even to the developers as well. They couldn't tell the difference if this was actually React Native or Flutter. And of course, neither could an end user. We would have Flutter and React Native on the same screen, and it would just appear to be a seamless app for them as well. The integration was that seamless. Again, all of this is possible because React Native is native. It respects the platform it's building on top of. I see it as more of an orchestration layer that enables you to opt into the JavaScript ecosystem of tools to manage your native application more agnostically. By using React Native, I don't feel like we're losing out on anything. I don't feel like we didn't have anything we had before. Quite the opposite. I feel like we're gaining a superpower by opting into the whole ecosystem that React Native has to offer to enable all of the different things that we're doing. Now, I spent a lot of time talking about the why and how of our process. Let me take you through what we've actually built. So this is the Guild homepage. It's entirely built using React Native on the web. Navigation system transforms around user input to be responsive in different devices. That animation is done using React Native Reanimated. There's a subtle effect there on the hero section. I'm not sure if you can see that. That's built using ExpoGL. So that's rendered to WebGL on the web platform, of course, but again, it's fully cross-platform compatible. So that's, that kind of cool gradient effect is done using ExpoGL. Let's just take a moment to look at it. So this animation is again done using React Native Reanimated, and all of these are just straight up React Native components. They're all interactable. When you hover over things, you know, the button state changes, you can click on it. A React Native modal opens. And as we scroll along, this section down here, this was kind of cool. So these avatars were actually created using Midjourney, so those people don't exist. And the crazy thing was these virtual avatars were Midjourney AI recreations of the in-person avatar. So it's Midjourney on Midjourney for that. Again, all done using Reanimated. This section here, these are rendered using React Native Yoga on WASM in a Cloudflare worker to create those SVGs. So even these images are created using React Native. And again, animations done through Reanimated. So the only part of this whole app that's not actually React Native is this animation, because if we were to do that, we'd probably want to pull in React Native Skia, which has about a 6 megabyte payload on the web. We didn't want to pull in 6 megabytes for our home page, and so we built this actually using a web-specific canvas renderer that's completely custom. But just that one bit is not React Native. Everything else is. And then at the bottom, I mean, of course, there's another React Native modal for you. So that's the power of React Native on the web. So by looking at our app, again, would you even be able to tell that was React Native, or does it just feel like a web app? Does it just feel like any other app that you might use? It doesn't feel like a React Native application at all, in my opinion. But fundamentally, what does all of this mean for you? Well, the way that we think about it is that we have our UI and we have our API. Both exist as mechanisms of using Guild. Users can use our UI to manage the platform as part of a first-party UI, just go to guild.host and do everything on there. Or they can register for our API, manage their secrets, figure out the queries they need, perform the mutations, and build a whole UI themselves. And this might be fine if you want a completely custom experience and you have all the resources to support it. But there's a big gap in between there, between UI, and API in terms of experience, usability, and effort. What if we can bridge that gap with embeddable experiences where you can take any part of our UI and place that where the traffic exists, regardless of platform? What if Chain React wanted to use Guild for event registration and opt into our platform? They can just take our event button and just put that on their page itself, right? It should be as easy as that. So all of this got me thinking, what if we took embeddable experiences seriously? What if third-party UI was the same as first-party UI? What would that actually look like? Well, right now, we have all of the various parts of our app built inside our design system, and these individual components composed together using React, obviously, that I spoke about earlier. I'm sure a lot of you do this as well. That's kind of how React works after all. You just mount components. If you're using Storybook, for example, I'm sure you already export all of it out to Storybook. So what's the real difference there? Can we just take those individual building blocks and treat them as embeddable experiences and just render those embeddable experiences directly into our UI? So obviously all of that's possible. That's how React works. But the main gap there is actually making that embeddable across any platform. We had to write custom logic to essentially contain these experiences to work inside other experiences. And that's the part we need to work on improving so that exposing these third-party experiences becomes as easy as just mounting a React component. Furthermore, right now, we aggressively code split our SDK to only load the JavaScript required when you use it. But what if we could leverage something like island-based hydration to only load the parts that are truly interactive, thus bringing down the web bundle even further? What would that look like in a truly embeddable world? And how can we make that easy for everyone? And so for us at Guild, that's our next frontier. It's critical to our business to support communities everywhere in whatever shape and size they come in, on every platform that they're on. We need to exist where the traffic exists. And that's what I told Mark back in Australia. I look forward to coming back and telling you more about our journey as we work towards finalizing and open sourcing this work to make it easy for anyone to opt into the infrastructure that's worked so well for us. And I can't wait for that. Awesome. Until then, thank you so much.